Thank you, Todd. Thanks for joining us. As I said, as Todd just said, please bug him in the hallway if you see him. Should be here all day. I'm happy to introduce next Cloudera's Chief Security Architect, Eddie Garcia, who's going to talk here about risk management. Eddie.
Good morning, everyone. It's hard to see up there. So my name is Eddie Garcia. I'm Chief Security Architect at Cloudera, and we're going to talk about security and how we're going to protect data and reduce risk. So before we start, I just want to get a quick poll of what kind of a technical audience we have here. So how many of you have hands-on Hadoop experience, have implemented, installed, configured Hadoop? Okay, that's a very good number. What about security expertise? Has anyone here configured any of the security things around Hadoop? Okay, there's a good show of hands as well. All right, let me find the clicker here. Okay. So this is a slide that you're probably familiar with, that you've seen before, and this is our one platform, many workloads. As you understand, Hadoop has many different things it can do: process data, ingest, transform, discover, all these cool things you can do with Hadoop. One thing that people sometimes don't really focus on is that blue line going across all those different areas, which is security and administration. And that is a very important item, that all of these modules, all of these different things you can do within Hadoop are tied with a good security framework. And we do that with a couple of things. We do that with Cloudera Manager. We do that with Cloudera Navigator. And there's ties into existing things like Yarn and existing operating system users, and to be able to pull this all together and be able to take advantage of accessing your data securely within HDFS or within HBase. So this is something that is extremely important for many of you to protect the data within your environment. When you're loading sensitive data, could be personal data, could be healthcare information, it could be financial transactions. It's extremely important that you have all the security features that you're familiar with in very legacy environments. How we do that? To achieve security, there are four main pillars of security. Any of you attended my session yesterday on this? Okay, there's a few show of hands. So this may be a little bit this slide will be a little repetitive from yesterday, but I want to reinforce again for everyone else the four pillars of security. So around perimeter, starting with perimeter, is how do you allow users to authenticate into the system? So when we talk about security, there's three basic A's that are fundamentals: authentication, authorization, and audit. Those are three fundamental A's of information security, and we start with authentication. It's important that every user comes into the Hadoop platform with their own login and password. You don't want someone going in and using the HDFS user, using the HBase user, using a generic or sharing credentials. It's very important for security that everyone is coming and logging in with their own login and password. And many times in corporate environments, these are tied to some Active Directory or to some LDAP type environment. You want to have that centralized identity management system where everyone is using that same single password to log in. This is really fundamental building block for everything that comes after that. We do this with Cloudera Manager. Within Cloudera Manager, we have an Active Directory integration wizard that allows you to easily connect to your existing environment. It creates and set up the types of accounts that are required to be able to run your Hadoop platform. Once you have that, then we can move on to defining what users will have access to. We do this with Apache Sentry. So Apache Sentry is an open source project that defines role-based authorization. So basically, you define a role. So you have someone in your organization that maybe is in the fraud team. So you have a fraud analyst role. Maybe you have someone in your risk team. You have a risk management role, or you have someone even in marketing that has a totally different use case for the same Hadoop platform. So you want to define roles to be able to define what users will have access to, really segregate the data so no one has access to data they don't need to. So the concept of least privilege can be enforced. So only if you need to have access to the data, then you can do it through a role, and those roles have access to the data. We do that with Apache Sentry. Then we can move on to the visibility, or basically the auditing. But it's not just auditing, it's also lineage. How many of you are you familiar with lineage or provenance? Those kind of things important for you? Okay. So basically being able to understand where data came from. So many times in a Hadoop platform, what you're doing is creating new data sets. So you start with a large data set with data that's not clean, that has a lot of noise, that needs to be tuned, filtered, and then you generate a new data set off of that. And then off of that new data set, now you do some analytics and maybe aggregate it with another clean data set, and you create yet another data set. So you're creating all these new additional data sets with cleaner, better data that's really getting you towards the insights or the answers that you're looking for. And along the way, you want to be able to understand which users touched data around that path, where that original data came from, what were the security conditions of that original data, and are we still meeting those at the end? If we started out with a data set that was only visible by maybe the fraud team, well, the end data, is it still visible to the fraud team? Are you still applying all the same security permissions on the data? Or have you now accidentally opened it up and it's open to the entire Hadoop user base? So you want to be able to do that within Cloudera Navigator through its lineage. And then the audit, again, is being able to see who touched it, who did a read on it, who actually modified it, who downloaded it. So being able to understand all the operations that happen within the Hadoop platform, Cloudera Navigator pulls those logs, audit logs, access logs from your HBase, from your maybe MapReduce job, maybe from your Impala query, pulls all these logs together and allows you to centralize how to do a way to search and to see what users are doing within the platform. And then from there, yeah, you can export it and put it into a syslog or to some other environment. You can do backups, or you can do even publish and subscribe type messaging, where if you're seeing that maybe someone that typically doesn't work with a data set is suddenly working with it and doing large downloads, maybe you want to kick off an event and send that to another environment that will raise a flag for someone to actually look into it. So you can do these kinds of things within Cloudera Navigator, and it's part of the monitoring and auditing of the platform. Being able to do discovery as well within Navigator allows you to discover what data is out there. So you have when you have a large platform like Hadoop and you give users access and empower them to actually uploading data, new data sets that someone may want to look into, and tag it, say, well, this data set should be marked as confidential, or this data set, we only want to retain it for no more than a year. We want to then after that purge it or delete it. So you can do tagging of these data sets within Navigator, and then really start the process of doing data lifecycle management and governance. And the last pillar being around data is how do you protect this data from some of the root or privileged users. So once you have environment, you have maybe system administrators that need to perform backups, need to perform their patches. You want to give them privileges to be able to do that on the system, but you don't want to give them access to the data. So a way that we do that is through encryption. So encryption allows us to have system administrators, privileged users that have access to these systems, but only in encrypted form. So they can have access to all the data that's on the data node, but the administrator can't actually see it. They can perform a backup of the encrypted data, but unless they have access to the encryption key, they can't actually unlock the data itself. And that's really important. That creates the separation of duties where you have a system administrator that has access to the data, but encrypted form, can perform his operations, but not the key. And then you have someone in your information security department, maybe a key administrator that administers who has access to the key, but you actually don't give them access to be a system administrator on that system. So it requires more than one person to actually go and try to take the data and the keys. We do this with built-in Navigator Encrypt. So within the Navigator suite, we have Navigator Encrypt that allows us to encrypt data that's outside of HDFS. HDFS itself has native capabilities for encryption, and then with a single key management solution that is part of the platform, which is Key Trustee. So Key Trustee is, think of it of a secure vault where you store keys. So you have encryption keys, then you define policies of who has access to these keys, and when do they have access. That's really going to complete the security capabilities that are required to have a fully secure Hadoop platform. I'm going to go into these a little bit more detail. Especially the last one is where I'm going to dive into encryption key management. That's typically where we get a lot of questions from our customers. The first one's, concepts that people are familiar with: login, password, Active Directory. There's, of course, configurations. We make it easier through Cloudera Manager. There's access. People are familiar with this. SQL, do a grant on a table, grant select, grant insert, or grant update. So these are familiar concepts as well. The audit, of course, logs have existed forever. Just log servers, very similar type of concepts. So encryption is more and more important, and it's really where some of the organizations stop. So they start with the first three. Encryption, well, we're tight on our deadline, so we're just going to push that to our next. And that's where organizations get stuck. So that's what I wanted to talk about, encryption, what we can do there, and within the Hadoop platform. Let's see. Okay. So what is HDFS encryption, and why do I care? Okay. So I think everyone should care here if they have some data sitting within Hadoop. There are many reasons to protect the data at rest. There's regulations, of course, HIPAA, PCI, FERPA, FISMA, or just any company confidentiality or internal information security type requirements. We want to protect this data against rogue administrators, compromised accounts, and lost or stolen hard drives. So I'm going to go through a few key concepts. Now, this is going to be a bit of a primer. If you want to really go into how everything works, there's going to be a workshop this afternoon. I believe it's at 1. Is that right, Mike? Yeah. So at 1 o'clock, so we have a workshop that's going to go into much more detail of every single of the 4 pillars, going through some hands-on examples of what this looks like. So this is going to be a good primer to be able to go into that workshop with some of the basics on these concepts. So AES, common cryptographic algorithm. Key sizes are typically a 128. That's by default what it uses in HDFS encryption. And you can increase that to 256. RSA, it's basically a cryptographic algorithm. It's used commonly to exchange keys. So you start with a higher level of encryption. You exchange keys to say, okay, me and Mike, we're going to say, okay, here's my RSA key, give me yours. We're going to share a secret, which is an AES key. And now we're going to take the conversation forward just with the smaller key, AES, for performance reasons. So that's how typically RSA keys are used to encrypt other keys to kick off a communication. And GPG is an open source implementation of PGP, which many of you may be familiar with email type encryption. But it's really for secure data exchange. And we use all 3 of these types of encryption and cryptography within the HDFS encryption, Navigator Encrypt, and Key Trustee. By the way, we don't have to wait for questions till the end. So if there's a question on any of these, just let me know. We're going to try to go into more and more keys, and so I want to make sure that each time we take a pass, that's really ingrained. So there's a lot of keys. So there's keys to encrypt the data. Those are the most common ones. So you take a key, like an AES key, and use that to encrypt data that's going to be sitting within Hadoop, or even outside of HDFS. Anything that's encrypted with a key. Now, there's other types of keys. There's not just that key. There's key encryption keys. So that key that is going to be used to encrypt a file that's sitting within HDFS or sitting within the operating system generally is going to be encrypted by a key encryption key. So you just need to protect the key. So it's levels of keys. And then there's the public keys. Public keys are pretty interesting keys. Anyone here familiar with the Diffie-Hellman? Okay. Recently received a award, Turing Award. So public keys are really interesting. You can think of it as a key. There's two keys on a door. There's one that can only lock, and then there's another one that can lock and unlock. So public key is one that can only lock. So you can only encrypt data. So I can take a data set and say, I'm going to use my public key or someone else's public key, which is usually the case. I encrypt the data, and I can't decrypt it, but the person that owns the private key can decrypt it. So again, I'm going to point to Mike. I'm trying to keep him on his toes there for a session this afternoon. So I take Mike's public key and encrypt the data set, and then send it over to Mike where he can decrypt it. I can't decrypt it. So those are public keys. Then private keys are used both ways. So I can encrypt data, or I can decrypt data. So we use all of these concepts within everything that's going on behind the scenes within HDFS encryption, Navigator Encrypt, and Key Trustee.
So this is an encryption for the data at rest.
It is for the data at rest, and let me just repeat the question because I think we're recording. So the question is these keys used for the encrypting the data at rest? So the answer is yes, but many times this will also protect the data in transit. So it depends where you're encrypting the data. So if you encrypt the data before you send it, now you're also protecting the data in transit as well as at rest. If you're only doing it when you receive the data, then, or before it writes it to disk, then you're only doing it for the data at rest. So it could be both, and and in this case, when we're talking about HDFS encryption and the encryption zone here, in this case, it's actually encrypting the data before it lands into Hadoop. So if you let's say from your local laptop, you're doing an HDFS copy of a local file into Hadoop, and you're using the Hadoop command line, and you're actually doing it into encryption zone, it's encrypting the data on my laptop before it goes into Hadoop. So it's also protecting the data in transit.
So my question was actually, like once the encrypted data we are querying, what kind of delays are there, latencies there?
So performance, what are the performance overhead of encryption? I'll talk a little bit that when we talk about optimization. So that's a good question, and let's return to that one when I get to that point. Good question, thank you. So we talked a little bit about HDFS encryption and encryption zones. So you can think about within HDFS, you have maybe the user/foo and you have a user/bar directories, and you want to create those as two different encryption zones. So which means that only user-foo can see his data. He is the only person, foo only has access to his encryption zone key, and nobody else will have access to that encryption zone key, including the HDFS user. So the HDFS user can still see the file that are files that are in the user/foo directory, but they're going to be encrypted, unless the HDFS user also has access to user/foo's key. So this is really powerful. So this is where you're really being able to create with a multi-tenant type configuration where you have users that can define what data goes into their HDFS directories and maintain ownership of the keys and ensure that no other person on the system has access to their data unless they've also granted access to their encryption key. Once you create an encryption zone, all the files underneath, let's say that user/foo's encryption zone, all of the files that get created underneath the directory and subdirectories are going to be encrypted. So every time I do an operation, and this is all going to happen behind the scenes by default. If I do a copy or if I do a move within that encryption zone, then those files are going to be encrypted by default. Each of those individual files has their own encryption key. So that's a data encryption key. So you may have, let's say, under use/foo, you have files A, B, and C. Well, that means that you have 3 different keys, one for file A, one for file B, one for file C. And the way that you protect that is that the encryption zone key, the key that's the master key for that encryption zone, is going to encrypt each of those keys and then store it in the metadata for that file. So far, you're following me? Okay. The way that this all happens is that there's that encrypted key for the file, which is called the Encrypted Data Encryption Key, or EDEC, is going to be basically passed around and generated from, and this is where it gets into more detail into the workshop this afternoon. It's what gets passed around and what gets stored in the metadata. And then there's operations of who can decrypt that encryption zone key. Yes?
You had talked about a key store, key trustee. Like, where are you storing these? So where are you?
We need to open the mic.
Oh, sorry. I'll just talk about it. Thanks.
It's open.
Oh. Yeah, it works. So I was asking, where are you storing the keys? So I know in AWS they have like the high security model where they store most of these private keys, public keys, whatever. And like, where you, I guess maybe in the workshop later on you'll talk more about it, but where do you recommend, or where does Cloudera recommend storing these keys as an admin, if I was an admin?
So the keys get stored, and I mentioned this in the previous slide, in the key trustee. So key trustee is where these keys are going to be stored ultimately. And not really the root of trust of keys, because as we went through this, there's several layers of keys. So there's a key that's for a file, there's a key that's for the encryption zone, and the encryption zone key that's going to be stored within the key trustee server. So basically, and it's going to be in more detail this afternoon, but we have a built-in key manager. So you mentioned AWS. So AWS has something like a Cloud HSM. So something very similar to that, but that's Cloud HSM within AWS is a hardware appliance that they need to rack up, and then you get to store your keys on there. And I think they have a new solution as well for key management now that is software-based. But key trustee is basically the same thing. Or if you're familiar with maybe Vault as well, Vagrant, using Vagrant, very similar. So you have a software-based solution where you can store these keys, typically on a separate server, because you only want your information security department to be the only ones that have access to that server that has all your keys. So it's part of the solution already. It's called Key Trustee, and I'm going to go a little bit more into that. Oops, skip that. So how does Key Trustee communicate? So it's all about creating this initial trust. I mean, it's like we can trust ourselves, the client's Hadoop with the key server, and then now you can exchange keys, and now you can identify, should I release this key to you or not? So that's done through actually GPG. So GPG, very common way to exchange keys. If used, for example, with email, if you want to do an encrypted email, we can use both a GPG, install it, and then we can now be sending encrypted email over our regular Gmail account. So GPG is a very commonly known way of doing that. Well, this is a very similar way how Key Trustee communicates server with each of the nodes within the Hadoop platform to be able to create that trust and then do exchange of keys. And then there's this last tier of keys that can be stored within physical hardware. Anyone here familiar or have requirements with HSM? So one, not many. Yeah, it's not that common. Some in the banking, some of course in government, where they have FIPS 140-2 level 3 security requirements, where all these root of trust keys need to go into a physical appliance that is actually tamper-proof. So it has these things that actually, if you go and try to mess with the internals of it, it has acids or something, it actually melts it down, so you can't really even physically tamper with the hardware. So it has ways that those private keys never leave that physical device. And we can tie into that. So we can have our key trustee tie into that if an organization has FIPS 140-2 level 3, where they have requirements to have this physical hardware appliance that protects the keys of the kingdom. Okay. So I mentioned two things, key trustee, but there's also something called KMS, and sometimes they get confused. So this will be a good primer as well for a workshop this afternoon to be able to not get them confused. So KMS is part of the Apache Hadoop platform, and it serves as a proxy into the key repository. So KMS basically does the functions of working between to fulfilling key requests, to generate a new key, or to send a key. And then it goes back to the repository, in our case, with key trustee. Or if you use the Apache Hadoop download from the website, the default implementation is going to be just a Java key store. So Java has its little built-in key store that stores to a local file that's not very well protected. Typically won't have a password, or the password is password. That's what it does by default, just for development and testing. But for a production environment, you want something that's scalable, that has redundancy, and that is much more secure and has key policies, which is our key trustee. So Navigator Key Trustee provides those capabilities. It's not open source. It's part of a Cloudera Navigator suite. So with Key Trustee, you can store these keys, and it's built into the platform. I mentioned already, it can integrate into FIPS 140-2 level 3 HSM. Let's see, so we already mentioned it acts as a proxy. The other thing that KMS, it understands Kerberos. So as you go, kind of going back to the 4 pillars of security, we talked about the first one being authentication. Authentication, login, password. That's where really Kerberos kicks in. So the Hadoop platform understands Kerberos natively. You know, it's technology developed a long time ago, very mature, out of MIT. And it's a way to basically have a distributed system, authenticate, and pass those credentials across the system. So I log in as user Eddie into one node, and that node is going to kick off or spawn off a job with 3 other nodes. It's going to continue to pass those credentials through Kerberos tickets. The KMS server understands that. So when it receives a request from Hadoop, it says the user Eddie wants, or user foo wants to have access to his key, and the KMS is going to authenticate, says, yes, this is user foo, so let's pull his key for him, and then he can decrypt his data. The key trustee and the Java key store really don't know anything about the Kerberos users. They just trust the KMS. So the KMS has already established trust with the backend key trustee server and says, if you're vouching for this user that is user foo, then I'm going to give you the key. You're saying it's user foo. So that's where really some of the differences between the KMS and the key trustee. It's also at the KMS level where you create your blacklist of users. So that's where you can say all the users on the system will not have access to user foo's key, only user foo. Or you can say that the HDFS user does not have access to user foo's key. So you create those ACLs, whitelist, or blacklist within the KMS environment. Again, this is where you create separation of duties, where you don't have like a privileged user like HDFS that has access to all the data within Hadoop. You can have access to all the encrypted data in Hadoop and all the data in Hadoop. So this is what some of all the different modules that we've talked about, how they all tie together. So you have a HDFS that's working through the KMS proxy to talk back to the key trustee server, store, retrieve keys. The key trustee server actually uses a Postgres database where it stores encrypted all these keys, and optionally may have an HSM, and there's a connector called key HSM that's going to tie into that. And then if you're encrypting data outside of HDFS, there's a Navigator Encrypt client that allows you to encrypt the data that's outside of HDFS. So a configuration file, a log file, a temporary file, anything that's basically going to hit a raw disk can be encrypted with Navigator Encrypt. So you have a single solution to encrypt all the data and meet the security requirements. So just quickly, a few kind of tips here for planning, encryption, key management. So again, going back to the 4 pillars, it's really the last one where a lot of organizations get tied up. So pre-planning, it's always best to set up encryption before you load the data. So it's kind of that thing where organizations say, well, we'll just worry about it later. Turns out it would have been a lot easier and a lot faster if you set up the encryption first. It's much more expensive to try to encrypt the data once you've already loaded it, because now you need to move the data, which when you're talking about terabytes can be slow, and then it needs to replicate across all the nodes. And if you also need many times twice the amount of space available. So if I had already 100 terabytes of data, I'm going to encrypt it, I actually needed another 100 terabytes of free to be able to now copy it over from non-encrypted into encrypted, and then go delete the original one. So it's going to take time. Plus, once you have data that sensitive data that hit disk and clear text, there's all these tools to scrape the disk and recover them. So it's, unless you do a DoD type erase, which in HDFS, I'm not really sure how you'd actually try to accomplish that. So the best thing is always to encrypt the data first. Plan for extra servers for your key trustee, for your KMS. Again, these are servers that you want to have protected, owned by your information security department. And of course, it takes time. So again, it takes time to encrypt data. Basically, you're going to recopy all the data again. If you're tying to an HSM, there's at least one hand that came up that has HSM requirements. You're going to need your vendor required jars, libraries, be those from SafeNet Luna or Data Secure or Key Secure or Thales Encipher. Any of the HSM, they have their clients, they have their jars. Those are going to be required to do the integration to the key trustee. So kind of wrapping this back up visually. So you have a single, within your Hadoop platform, a single key management system, and for your production environment, key trustee, optionally an HSM. You store keys from either 2 places. One, the lock in red, which is HDFS. So all the data that's within HDFS, all these encryption zone keys will be protected by your Navigator key trustee. Then for anything that's sitting outside of HDFS, maybe you have a metadata repository, MySQL, you have temporary files, you have spill files, log files, configuration files, any of these things that are sitting outside of HDFS, all of these can be encrypted with Navigator Encrypt. So performance. Going back to the question about performance, we typically see overhead of performance in the single digits, so less than 10% on CPU and IOization. So you're going to have CPU hit because it needs to actually use processor cycles to encrypt or decrypt the data. And you're going to see I/O because it's going to slow it down. Now you're going to create some latency. But we see those typically in the single digits, less than 10% overhead when you apply all the encryption, which is, when you think about a distributed environment, you can easily recover 10% if you wanted to by adding another node or another resource. So it's typically not an impact and something that really should be encrypted by default. And again, going back to try to encrypt the data before you actually load it into your Hadoop platform. We also are a partner with Intel, and we're able to optimize Hadoop processes, take advantage of on-chip hardware encryption. So for example, AES-NI. So that's on hardware execution of AES. That is much faster than doing it in software. And with that, we're able to optimize and tune the environment to get into lower single digits. We've seen down to maybe 3% overhead of CPU and I/O latency when taking advantage of the Intel on hardware execution of encryption and decryption. So we have a table here. You probably can't read it, but there's some rules that we have, or some guidelines around what data, when you should use Navigator Encrypt, when you should use HDFS encryption, kind of how do you prepare that, when to use Navigator, or where to use Key Trustee. I can make that available to you. So going back to those that are using Hadoop, or even better, using Cloudera distribution, when you set up a cluster, what we recommend is to have the key trustee actually in a separate cluster. So if you go into your Cloudera manager and look at the clusters, you should have one production cluster where you have all your different roles for name node, job tracker, HBase, all those things. And then you have another cluster that's separate just for the key trustee. And you have a key trustee administrator that's going to have the permissions to that cluster. So again, creating that separation of duties. This also is going to enable you to do, for example, upgrades easier. So you can upgrade the entire cluster, not worry about the key trustee, do that later. Key trustee at that point becomes a really critical point in your environment. So you want to be able to do that. So this is going to go just a little bit very quickly, repeat into what I had mentioned, that when you encrypt data with HDFS encryption, you're actually encrypting on the client. So in this example I gave was maybe off of your laptop, you're going to copy a file into HDFS. You've already defined an encryption zone within the HDFS. You've created an encryption zone, and now you're going to write a file. So quickly, let's see, we have 4 minutes. We're going to go in more detail this afternoon. So very quickly, I just want to point out here that the file is encrypted on the client. So it's the client that's going to talk to KMS to basically say, give me an encryption key, and then it uses that encryption key to encrypt it before it goes into HDFS. So all these steps that you see, 1 through 8, of all these files and headers and keys being exchanged, it's happening behind the scenes. You don't need to do anything. The only step that you need to do was define that user/foo as encrypted zone. And then from that point forward, all these steps are happening behind the scenes, and the data is being encrypted before it goes into HDFS. For reading the file, same operation happens. Now you have this client that needs to read a file, but to be able to read the file, it needs to actually get the encrypted key. So it's going to make the call out to the KMS, which then is going to also call the key trustee. And it's going to retrieve that key if it's user/foo that logged in, that did that KINIT, and that is user/foo, and has permissions based on the whitelist, then he's going to get the key and be able to read the file off of HDFS. If it's any other user, not that's one that's on the whitelist, it's going to deny access to the key and is not going to be able to decrypt the data that's within HDFS. All right, so with that, I'll open it up. We have a few minutes here, a couple minutes for questions. I think we have a mic over here.
So actually, I have a question on that. With regards to migrating keys, if I've already encrypted my data, what's the impact when I need to change the key and routine maintenance?
We can't toss you the mic all the way up there. But, so can you repeat, just repeat again, please?
So with regards to the key management, let's say I've encrypted a petabyte of data and then 6 months later I need to change that key. What's the impact? Do I have to go all through for that?
So there's several levels of keys that you've heard. So rotating, for example, the encryption zone's key is very simple. So if you have a petabyte of data, and let's say it's all in one encryption zone because that's all you need, and you can rotate the encryption zone key. And what that would mean is that any new files are going to be protected with that new encryption zone key. But all the previous files are still going to be using the old encryption zone key. So there's really, but take it that each file has its own key anyway. So it's only the key that's protecting the file level keys, the encryption zone keys. So you can do that. It's very easy. It's one simple command. From that point forward, all using a new key. And then you can go delete the old files and then kind of do that over time if that's kind of the strategy or works with your model. If not, you can always copy the data. That's going to create a whole new set of keys. So you can say, I have a petabyte of data, and I'm just going to copy it from encryption zone. I'm going to rename it to petabyte old, and now I'm going to create petabyte new, and then I'm going to copy all the data, and now it's going to be all re-encrypted with a new key. Other questions? All right, I'll also be available at the break. And again, if you want to go into much more detail than I went in through, there's a session, a workshop this afternoon that's going to go through all the 4 pillars, give you demos and examples of how to configure what we talked about within Sentry or the authentication or the encryption. Thank you.